Hello everyone, it's August the 8th. Alright, let's see what we're gonna have. I think we've been failing every day for quite a while, so I hope this one is not that bad. Oh, and this... Oh, we haven't even dealt with this one yet. Ah, Lord. Return true if it is power of 2, otherwise return false. Oh. I've done this before. Some bit manipulation, right? So power of 2 is 1 followed by lots of zeros. So in order to check if this is the case, we basically say if I AND with this, it's going to be 0, which this is this one minus 1. So what I need to do is n minus 1 and n needs to be 0. I think it should be this. N had to be larger equal to 0. Oh, that's Java. That's why things feel wrong. I think I need to swap the position. Always some edge case that you fail to realize. Alright, so that's it. Upper right corner, see that he can only move above the main diagonal and cannot cross it. Otherwise, he won't be able to reach the lower right corner. Yes. The same constraint applies to the one on the lower left. Since the 3 children are not allowed to enter the same room, we only need to consider one of these 2 diagonal symmetry cases. We can use dp to compute the maximum fruits collected along one valid path, and by flipping the matrix along the main diagonal, we can reuse the same logic to compute the other path. This transforms the problem into start from the top right corner without passing through the main diagonal. Find the maximum number of fruit that can be collected by the time the child reaches room n minus 2, n minus 1. Yeah. This can be solved using a dp. Let this represent the max number of fruit that can be collected when reaching room this. Max that can reach here. For max number of fruits that can be collected when reaching this. For this and then this. Column J is always greater than I. It's like this doesn't seem to be any trick. They just use the most basic dp. n minus 1 minus I. I don't understand that part. I think that's a diagonal. Okay, what if I equal to 0? If I is 0. J is n minus 1. If I is 1, J can be and this is just to say where J can be as I increases. So if I increase and J, like on the second row, maximum J can do is indeed here. And then next one indeed is here, next one indeed is here, next one indeed is here. And to compute that, because I start with n minus 1, right? I start with n minus 1. So it keeps getting smaller, each one minus I, yes. But I need to pick the larger of the two. Because yeah, every step j is bigger, that means you are restricted to the top right corner. So you have the smallest I is going to be I plus 1, right? And the biggest I is going to be n minus 1 minus I. So this basically defines what j can be. So like this is just a regular DP. I'm surprised that it will work. What was your objection yesterday? Not yesterday, the other day when you first saw this. What's your objection? Well, now my objection is if I say the max, I was thinking the max starting from this, right? So max starting from this will be the max of this and this, all those three added together. And max of those will be all those three added together. And eventually you will have edge case where the last one, right? You'll have the last one, so maximum taking this, you know, because that's the last one. It cannot keep moving anymore. Therefore, and it also cannot move across the diagonal line. Oh yeah, so essentially this one you know, and then for this one, I cannot go diagonal line, I can go here, I can go here, so this one is also no. The maximum here is 15. Maximum here will be, the only one you can do. Maximum here, because we got this, we cannot cross the diagonal line, so with this. So we can do this all the way back, and we just need to know the maximum starting from here, which you can go this way, or this way. All right, and then but we just keep going back, and then we'll flip it, and then we'll do it again. That does seem right. I think we can do this. But I'll do it differently from the editorial. Editorial worked on the right half. I'm going to work on the bottom half, which also is more intuitive to me. Okay, it's also more intuitive to me. And essentially, we'll start from this position, and it cannot cross. Right, that's the key. It cannot cross the a diagonal line. Because if you cross the diagonal line, then it takes you more step to reach. So you cannot cross. And also the diagonal line is already all taken care of. So also that's why you cannot do the diagonal line. So all you can do is when you hit a position, you shouldn't go beyond. Like, what does it mean by go beyond? So on this diagonal line, your row and a column is the same. And on the bottom half, your row value is always larger than your column value. So that's the restriction. So for each one, you can go like 3 different directions, right? 3 different directions. Yeah. Essentially, you're given this, you go 3 different directions, and the one that's beyond the diagonal line is not going to be considered, and this can be considered, this can be considered, and if it's outside, it's also not going to be considered. So we just keep doing, right? So we're starting from here, and then every step you move, because I am going to go J. Well, actually, J can start from here, right? And I mean, the editorial also have these arrays. What is this? These arrays do? Current and previous, and then they swap. I think this is to make it 2D, like a 1D, 1D instead of doing 2D. I'm doing 2D. I don't care. Okay, yeah, well, we'll do this. I'll do this some other time.